your client or here. We'll do an attack and we'll see how that is visualized from the client with the trace route that we are executing. And let's see how that looks on the router side. To refresh the MTR, please click on R and that should refresh it. And what you should see is something similar to what we see right here. When you refresh the MTR, you'll see that the path the information follows has changed. The path's changed to the destination. Is anyone seeing the same? So, how many do we have before the movement? Did anyone notice? 9. Many 9 hubs. And now there are 3, I think. I will start sharing my screen again, where we have the router. And right here, we will run the command, the show BGP command again for that particular prefix. Remember that we were looking at the BGP table status, 2803, column 9910, 8000, column 1, and what's changed? What are we looking at? First, what is the network originating that IP address? The prefix, what network does it belong to according to the BGP table? So the price is 1 cup. What's happening, who's originating it, and type of actions. Oh, well, that's changed. There are several questions in one for a cup. So what happened? What type of attack is this? And what's changed that we can see on screen in the information that our BGP router has for this path compared to the information that we had before. So please come up to the microphone. The autonomous systems changed and now we have 6502, and in the past we had, and before, yes, right. What he's saying that this changed the originated autonomous system. Before we had 64135 and now it's 65002. How about the network? The network the prefix belongs to. I don't know if you remember, if you look up, if you scroll up, yeah, it belonged to a 34/34 and now /48. So the originating network has changed. It is now originated in an autonomous system that is not the one authorized for that prefix. The more specific network segments are preferred. That's why the /48 is preferred over /34. Right, as Silvia said, /48 is winning over /34 as it is more specific. So the BGP tables using this one because this one's more specific. And if you look at the validation status, it says invalid. Why? Because this is breaching the ROA. The ROA said that this prefix needs to be initiated or published by the autonomous system 64135, and in this case it's being originated by 65002. Okay, so what type of action could be happening so you can win the cup? So what the mug? What type of attack is this? You please tell us your name. It is a path hijacking. Your name? Danilo Mendoza. Okay, Danilo, round of applause. He's won the mug. You can share the mug. You drink one drink each. So it is important to mention that these type of things happen. A path hijacking usually it's intentional. It is intentional usually because there is a human error. But at the end of the day, we need to be careful, and that's why it is an our PKI validator is important for issues like this. If we look at the settings, at the settings section in the guide, if you scroll down, you're going to find a section that says configuring BGP filters based on the validation status. So we have the router connected to the RPKI validator, and the invalid path is saying, or the information that we now have after being connected to this validator is saying that in the BGP table that this path is invalid. Now, when we connect the router to an RPK validator, and this needs to be very clear to all, connecting the router to the validator does not change the router behavior at all. The router is not going to filter or run or execute any action using the RPKI information unless I configure it to do so. The only thing the router will do is to add information to the path or the route table. So our recommendation is for you to install an RPKI validator and to connect at least one router to the validator. That will add information to the table which prefixes are valid, which are invalid, and which are not bound. That information, and we are not yet going to apply any particular filters, is very useful information when running a network. If you work in operations, you know that sometimes we have a routing problem and it is very hard, or problems that are very hard to purge, sometimes impossible. But let's say that they're very difficult to do on a path that used to be valid and now is shown as invalid. Well, you already know what's happening. The origin of that path has changed. I'm not filtering anything, but I am seeing, and this is a big help when purging a problem. So installing an RPKI validator, connecting it to the router, and having the information in the path table is very useful for those who work in operations. If you want to go a step further, you can apply filters based on the validation status, and then you will take actions based on that status. And that's what we will do. We will filter based on the validation status to try to mitigate the attack. So basically, what filter are we going to apply? A filter that will take the prefixes received from the peer through the prefixes that are received through the BGP session, and before installing the BGP table, I'm going to check which ones are invalid. If I receive any invalid prefixes, I will dismiss them. I will not install them in the BGP path table. If I don't do that, it won't be a valid aspect to route the information. In other words, if I eliminate from the BGP table all the invalid prefixes, I should have those that are valid left or not found, and that should solve the problem. So let's do that. Let's apply a filter, a BGP filter. We will change, or we'll apply the roadmap that's been created to take a certain action with the invalid prefixes.
Sí, estaba al principio de todo casi. Acá está. Acá. Entonces, el roadmap está aplicado.
So the roadmap is the one that says allow all. So everything that I receive, I will install in the BGP table. Now, I will change a different route map that it's called RPKI. This route map that we configured at the beginning, this route map says, and there are two permits, two sentences. The first one says, match RPKI valid, and everything that is valid will set local preference to 100. What is local preference? I have no prices left, but what is a local preference? It's a BGP attribute. Okay. And how about the outbound traffic? Almost, that is met. But local preference. He needs a microphone so everyone online can hear him. The question was, what is local preference? And the colleague said it is a BGP attribute. And we asked, what does the BGP attribute local preference do? What does it do? Okay, perfect. I will try to repeat what you said so everyone can hear. So he's saying it is a BGP attribute that lives only in my autonomous system, is not transmitted to any other autonomous system. I will set it up in the entry points of BGP publications who are using the eBGP protocol as the filter for those inbound blocks that announce me. And the more local preference that I have, the more weight that will be assigned to that route. So local preference by default has a value of approximately 100. Now what we're doing here is we're increasing that default value to 200 for all valid prefixes. That means that every time my router receives from the peer a BGP publication, a route with a validation status checked as valid, it will assign a local preference 200 instead of using the default value of 100. There's another sentence that says match RPKI not found. So all of the prefixes with a not found status set local preference 100, or that means the default value. If it's not found, it will have the 100 value. If it is valid, local preference will be 200. And what happens with those that are invalid? If I have a route map that matches something with everything that is not explicitly indicated in the route map. This is a more advanced question. When I have a route map that says permit, 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 everything that doesn't match with a permit, it is explicitly denied. It's like if I were stating the third RPKI status, in addition to valid and not found, is invalid. So I should have another route map sentence that says what to do with those that are invalid. If I add a sentence that says dismiss or deny invalid, if I don't write anything, it's exactly the same. Everything that does not match a route map, it's explicitly denied. Every time I apply a route map will be there, and everything that is not mentioned will be dismissed or denied. So there's no reference to invalid, so those that are invalid will not be installed. It will not be installed in the BGP table. Again, if it's invalid, I do not install. If it's not found, local preference 100, and if it is valid, local preference 200. Once I apply this in my BGP table, I will have no invalid prefixes. So the ones that are invalid should be dismissed, and I should use the other one that, although is less specific, if it is the only one available, I will use it. By applying this route map, when I eliminate those that are invalid, I'm clearing out the BGP table and mitigating the attack. So let's apply it. To apply, no, wait. We don't need to copy that. That's already been pasted. Here, configuring BGP filters based on the validation status. So to configure that route map, I'll go to my router, configuration settings, conf T. We'll go to our autonomous system configuration. You have to write router, BGP, and in my case, 65001. But remember that you need to use the number of your autonomous system. I access the BGP process in my router, and I will execute the address family IPv6 unicast command to change the settings of the BGP session for the protocol IPv6, and here I changed the route map. The route map that we have applied is one that allows all, and I will change it. I replace it with one that only allows this RPKI route map that we just explained. Again, let's review. Let you go to the configuration mode for the BGP protocol, address family IPv6, and you execute command neighbor fd3a colon d409, which is the peer or the neighbor address. And now you add route map rpkin. So we're going to change the ON to rpkin. Once you've applied this, we exit the address family, exit the BGP again, and exit one more time for the configuration mode. And we go back to executing the show BGP for that prefix to see show BGP unicast for that prefix. And what happened? Since I filter all the filtered out of the BGP also invalid, that IPv6 address is once again, according to the table, it has the original prefix /34. The originating autonomous system is the correct one, 64135, and that's why the RPKI validation status is valid one more time, because I eliminated from the route table all of those that are invalid. Did everyone follow? Were you able to do it? Okay, so now let's go back. Once you have finished this, let's go back to the client. Let's go back to our client where we have the MTR running and click on R for refresh. Let's go back to the client, click R, refresh. Did you click R? Well, no, you did something wrong. Click R. Did that happen to everyone? Is anyone seeing the original route? Please raise your hand if anyone sees the original route. What happened? Did we apply a filter? Shouldn't this be running? No, it shouldn't. Why? Can anyone explain? We should have another mug. What do we have left? A pen? We have a pen, but it is a great question. So the question is, what happened? We applied a filter. Everything's working. We filter the network. How come it's still not working? This is a very advanced ninja network administrator level. So please try to use all the knowledge available. Router is fine. What could be the problem? What do you think? Please raise your hand and let me know what you think. Let's brainstorm. The chief of operations called us all into a room and he asked to brainstorm. How does RPKI work? You're all fired if you don't have an answer. If you have no feedback or comments, you're all fired. So what are we missing? Or what do we have that is extra? Don't help them. In real life, they will not have this aid. Raise your hand and just give us your opinion.
Ocultó.
So Let's see what's happening. We're doing things correctly with the router. We applied a filter. The BGP table was updated. For us, the prefix is valid. However, we go to the customer, we do trace route, we send traffic to that destination, the traffic continues going to in the wrong direction. Why is this so? Why? Now, why is that happening? What type of protocol is IP? Is it connection oriented or is it not connection oriented? How did you, let's see. All right. The IP protocol is not connection oriented. In other words, each router, you need to know this. What I'm saying is just to to encourage you to say something, but it's not easy to realize, and and even less in the context of a presentation and totally disconnected from the problem. But in many cases, some people think about this, but you have to have a lot of experience to rapidly realize where the problem lies. Normally, what is happening here is what occurs. It's not so easy to pinpoint what the problem is. So, what is the case? IP is a non-connection oriented protocol. In other words, each router, regardless of the decision, the next hop makes the decision. I can have a beautiful path to reach that autonomous system. You have to follow all those autonomous systems. That was a BGP table. It tells me, it shows all the skips, all the hops in direction of that network. But in reality, does it mean that the packet will follow that path? That's not the case, because when it goes from my router to the following router, what I have in my router is no longer important. The important is what you have, thing is what you have in the following router. And that's the beauty of IP. So, if we recall the network topology, our router has a BGP session connected to the central router of the traffic exchange point. So that is where the traffic will be forwarded. Once the traffic reaches that central router of the traffic exchange point, who will make the decision of where it goes? It's the central router of the traffic exchange point. So what would be missing in that router to make this work? Not in my router. We already did things correctly in our own router. Now, it is a central router that is not doing things correctly at the traffic exchange point. What do we still have to configure in the traffic exchange point so this can work correctly? What autonomous system does the central router have? What does your peer have? 65,000. Look at the AS path. The AS path we had previously was my autonomous system, the first autonomous system. The next one was 65,000, and then 64,100 something, the one that originated all the things. Now it turns out that if you want to RPKI to work correctly, you have to apply the RPKI filters all along the path, not only in the router, because once the information reaches the router, in this case the central router, the traffic exchange point, because it has no RPKI filter at all, the route table of that router still has the false route, the false path. That router is still being attacked. It hasn't solved the attack. So until the same type of filter is not applied in that router, this situation won't be solved. So you have a path, you apply a filter over here, you solve the problem, but when you forward the information to the next one, this was not solved, and they'll try to send the information to the false destination. So let us see what happens if we apply the same filter in the central router. I'm going to access the central router in the traffic exchange point, and I'm going to apply the filter at the central router of the traffic exchange point. So very rapidly. Sylvia is doing the hijacking here. Just bear with me. It's not so easy to do it with just one hand. I'm going to put the microphone onto the on the table.
Ahí apliqué.
So you don't have access to what it is. So, but what I did here is apply the same filter, exactly the same filter that we had applied in our own routers. I then applied it in the central router, the traffic exchange point. So the BGP table of the central traffic exchange point, no prefix that is invalid escaped it. So if you go to your customer and refresh your client, where you have the MTR, click R, and did you solve this? So what does this mean? You always have to recall this. If I solve a local problem, if throughout the path someone keeps on having the problem will persist, because once the traffic reaches that place, it will go in the wrong direction. I have a long path. I repair this part, this part, this part, and this part over here. But if there's one part that hasn't been repaired, there you still have the problem. The same thing happens here. In the case of RPKI, all the affected path has to filter this. Otherwise, attacks such as these are not solved. That is why the route hijacking attacks are so difficult to solve. This not only depends on me. I have to coordinate things with a lot of networks that we have in between, with all the networks in between, and at least with my carrier. But coordinating with my own carrier is easy because I have a contract with it, but with the carriers of the carrier and the carriers of the carriers of the carriers. So until you detect a problem, and if you mitigate it, in fact, many days can elapse. All those who have had route hijacks, the major organizations, Google, Facebook, and so on, why do you think they took so long to figure out solutions to these problems? This is because they have money and they're enormous companies with a lot of expertise. But this is because it takes a long time. No matter the size of the organization, you have to coordinate things with several players. Those of you who work in operations are aware that routing problems can be solved locally, but you have also, very frequently, you have to communicate with others and coordinate things with others that don't depend on you. And you can only wait until and hope that the others solve the problems locally so that this is solved for everyone. So routing problems, routing issues are not so easy to solve. But you can see that this tool of RPKI is quite powerful. First of all, to implement RPKI to have information in the routing table, and secondly, to try to figure out solutions to the problems. And one step forward, once you have more experience, you can start to apply some type of filters based on the validation status in order to mitigate attacks such as these. Maybe it's not always running. Maybe you execute it when you have the attack. Maybe you don't wish to have it configured always. But in the event of being under attack, you have one further tool that you can use to mitigate those attacks of route hijacking. Nico, above all, we have this situation in which the route continues to be hijacked. But if we coordinate efforts, if we take those best practices, and if we as operators, we can make our own contribution, as Nicolas was saying, if we see this with our peers and we continue having these good practices, configuring the validation with RPKI, we can do something about this and we can mitigate any type of problem. For example, now with route hijacking. The route has been hijacked, but this won't be successful because we have this RPKI validation, the origin validation. Yes, I removed the filter over here in the central router, the traffic exchange point. You don't do anything in your router. You have to click on the R, and once again, suffering from the attack. We only removed the filter. Is it clear? So I will stop here. Over to Silvia and Santiago. I have to go to another room now. But I will be around all week. The three of us will be around all week. Guillermo and Erika, who had the theoretical session this morning too. So any comments, any questions that you wish to discuss, we'll be around and I'll be happy to help you. Now we're going to automate this practice now. We're going to look at a tool that we'll be using. We don't have too much time left. We have 50 minutes to do all the things that we did automatically. But first of all, let us have a look at the concepts of what automation is. So who of you works in automation for configuration purposes? All right, so the practice will be quite a good option. Basically, what we'll be using are tools that arise from the development of configurations of software and implementations. These same tools can be used as what we call configuration managers. These allow us to automate and control deployment tasks, operation tasks, and management tasks. There are many configuration management tools. These are some of the most well-known ones. After these, even more arose. We have Ansible, Chef, Jenkins, Puppet, CF Engine, which was one of the first ones. And we also have Salt. And more recently, others have appeared that can also be used. In the case of three of these tools, namely Ansible, Chef, and Puppet, we have a table here reflecting the main features of each of the options. There are many more, but the main ones are in the implementation language. Ansible uses Python, Chef uses Ruby, and Puppet uses Ruby too. Then you have the configuration language. Ansible using YAML, and Chef uses its own language, and the same with Puppet. Now the difficulty of learning is quite relative because each depends on the implementation and what it can do. You can have a simple tool but doesn't cover the needs we have. Another important thing is the architecture. In many cases, it's just like a master who executes a remote case, and then you can have an agent in each of the teams so that they communicate with the manager or with the maestro, with a master. Then the protocol is also important. Many use a secure shell, and here it is also used as a protocol for configuration. Others use REST. And then we have the management. In many cases, this is a pull management. In the case of Ansible, it's push and pull.
We are going to look at Ansible. It was developed by Red Hat. Red Hat kept the project open, and it has its own configuration tools called Tower, which is, well, not free. Ansible is. It's very widely used. We can see here the basic architecture. We're going to have a playbook that we'll see in a minute. That is the main file where the deployment starts developing, the users, and an inventory. In this inventory, we are going to see all of the devices that we want to work on. We can also have a database with all the information that we want, settings, and so on. The hosts where we are going to implement those settings, and the network is very important. What are Ansible's components? There are basically three architecture components. The first is the control node, the main one, and that is the machine where Ansible is installed. In general, it's not necessary to install them in other nodes other than the one that will administer. The administered nodes are the remote nodes that we're going to control, make the necessary changes, and the inventory is the list of such nodes where we're going to execute the tasks. Here is a basic diagram of the control node. We will have the playbook, that is the beginning of the task, the file that describes how to initiate these tasks, and the inventory where we have the nodes. Those nodes can be grouped by type of node. For example, if I have a Cisco router, MikroTik router, or any other brand routers, if I have servers with an operating system, some have Median, some have Ubuntu. Well, I can group them based on that, and I can also apply based on the type of node different settings because they're not all the same. It just depends based on the which one I apply to. Based on the playbook, I can run different tasks. I will run these through very quickly. Some of them call them artifacts, other components. These are different Ansible artifacts, and this is a summarized list. There are many more. But the most important ones are the ones that you have here: playbook, tasks, variables, modules, collections, and templates. The templates that I can use for developments and to share them. So the playbook is the file that I will initiate or start the execution, and I have a list of tasks. I have different elements like variables, hosts. I can include chunks of some files or tasks, one within the other. And this is basically what I will use to initiate and how I start these remote devices. So the task is associated to a module in Ansible. So I will have the code and I will execute something. That something could be something very simple, like installing a software package in a remote machine, or copy a configuration file, or more complex, like deploying the full infrastructure. I could deploy several things in several devices. Right here we can see an example, maybe reflecting something that we consider more complex, doing it on Ansible than Linux, for example, a command line. In the first example is how to install Apache. So for Ansible, I will name the task. In this case, is install Apache in HTTPD, and I invoke Ansible building apt, that module. That is one part. And then I have to tell them what I want to install. The name that you can see here is the name of the package, not the name of the task. And the state, I want the latest version to be installed. In Linux, it's very simple. We do apt install Apache 2 and that's it. And in my example, which is a very simple example, we are comparing how to execute a command in Linux and a task in Ansible. In the second example, it's installing the same but from a package. As you know, I have to download the package and install it. For example, dpkg. I will use the same module, but instead of the name, the module incorporates the possibility of installing dev packages. So the wording is quite similar when it comes to installing a package from the repository or from a package that I have downloaded at .dev. The variables. Like in any program, any software, it's the same. I will define values that will help me do what I'm doing more quickly or flexibly. It will, based on a variable value, I might run one task or a different one. So it's how I reuse things. I can define variables, and based on the variables, I will execute a task. Ansible is interesting in the sense that there are two types of variables called facts and magic variables. Magic variables are the ones that Ansible needs to create. And those variables that have names, I cannot, within a task, define it with the same name. Those are specific. When I execute something, I will need certain variables to finalize the execution. Now, the fact variables are variables that the remote host will have, and I can bring over. I can have the information of the remote host. For example, I say I will install a package in Debian remotely to 10 servers or 100 servers, and that's great. But I might need the fact for each and every one, because I have one device with a version and operating system and a different device with a different version. So based on the facts that I will bring over, I can generate different templates, different tasks that I will define based on the equipment or the version that I have. Now the modules are the foundation, and as we saw earlier, of what I want to install. There are two types of modules. Official modules are maintained by Ansible development team. And the difference here is that they have a high priority in terms of error correction. So if there is an error, there is someone that will update it. Now the extra modules are the ones that are maintained by the community. We can have, any one of us can make a development available to the community on Ansible. How do we do that? Well, those modules or those collections could be the official collections, like the ones that we can see here. For example, those are available for Cisco. That is a list of Cisco devices. If I want to install on iOS, I will use the cisco.ios module. Now, if I want to install in the Fargo Lasan, you can see the second one is cisco.asa. So at the same time, the modules are created with the details or the development for each, the operating system of each equipment. And the modules that we can develop, we can keep them in this community that is called galaxy.ansible.com. We need to follow certain rules to write them. There are certain requirements to fulfill. There are very few though. And we'll have collections that can be kept here and made available to the community. There's a case on screen In these practices, we're using FRR as the router that we'll use. Now, if I wanted to look for modules related to FRR, there's a list here, and then, well, I'll have to evaluate which one is better for me to use. And the templates are templates that we can use and reuse for different tasks. They are all based on what is known as Jinja 2. One more thing. When we use Ansible, we use everything written in text mode. Ansible allows us to code or to encrypt this. There is a module, well, rather than a module, it's called the Ansible Vault, and this will encrypt data that I don't want to be seen. For example, passwords, usernames, keys, etc. So I can encrypt a full file. Like right here, you can see the example. I will execute Ansible Vault create. It will ask for a password, and when I confirm the password, I will see that encryption. I can only de-encrypt it if I have the password. There are more examples right here on how to do it. We can use identifiers. I can use several passwords, several IDs, or a file that contains all of the information. And once I execute it, I provide the ID and searches for the keyword used for encryption. This can be used in, well, today's activity. We won't have time to do it, but we have a password, we have a chain. I will encrypt it and say, well, if my variable, I cannot see the cursor. So the string that I want to encrypt is the one right there, like a sort of password. When I execute Ansible Vault, I will see a password and then a set of numbers to encrypt it. So what are the steps? These are quite easy. So you install Python. Ansible is a Python module. And then we'll define the list of hosts. And there you have some commands to test it. If I want to automate it, I will need to copy the public key from the control machine to the ones that I want to manage. So that was for automation. And we won't have time to carry on. But this shows an overview of the status of the different protocols and so on for automation. There are different protocols. So this is more about the settings using devices that support these protocols like netconf, resconf, GNMI, and a data model. And on screen, actually, you can see it, so we can move on to the actual hands-on activity. But finally, here we can work on telemetry. We're not just going to configure a device, but also obtain data from that device. Whenever there's a change in that machine, the device will open stream and send me information. This works differently in SMMP. We'll have a pool. So from that device that I want to obtain data, the one that will, for example, grab an interface, I'll have to interview the router and bring it over. Now, telemetry helps us, like once is established, if we support the protocol, the device itself will inform that there's been a change. So that's what's new and the big advantage of it. I would imagine there are many questions, but let's just use Ansible in practice.
Bueno, y entonces, antes de que iniciemos,
So before we start, so in principle, we heard that you were not doing automation, but is there anyone here who has had some kind of experience with telemetry that you'd like to share with us? Nope. No one? Is he going to participate? No, he's leaving. So this is just to give you the last prize we had, just for having mentioned something. But no, apparently not. Anyone? So let's go on. We will have more questions. So we will now change gears. We're going to enter https://github.com/lacnog/rpki-labs. So that's the link. That's a link. So once you're there, go to practice guide on automation with Ansible and BGP Q4. Basically, we have the same network topology. Now, what we need to do is to install 2 packets. First of all, you can install the collection that we're going to use. This is a Cisco collection. The command is Ansible Galaxy collection install cisco.ios. So you execute that. Raise your hand so we can follow rapidly those who are making progress. Did anyone raise a hand? So the second task is to clone the repository where you have all the playbooks and the Ansible tasks. So the command is git clone and this URL where we have all the things we have developed in that repository. Those of you who finished, please raise your hand so we can advance. All right. To continue rapidly, what you have here is the tree showing the structure you have just cloned. So let us advance. And you have two tasks. One is in the hosts file where you have the X, you have to replace this with your group number. Okay, are you following us? Yes? Is anyone having any issues? The second task that you have to do, remember when you entered the main site, the main page, when you accessed the lab, there is a link at the top with router passwords. Each of you has a password. When you open this, you have to look up the password that corresponds to your group. All the groups appear there, and the one that has been assigned to you, and you select that password over there, which we will use if we follow the guide. We will use it for this file called variables_ios.yaml. So that will be replaced, this file over here, where you have Ansible password. We're going to repeat that with the string that corresponds to each group, the one that you have in the list. And where you have an X or two X's, replace that with your group name. So there are three things that you have to change here. The string that you saw just now that has been assigned to you, and the group name. The X in the autonomous system and in the router identifier, which says my router ID. So now let us very rapidly carry out these tasks. So in order to see if we can do the last one, I'm going to change directory. The one we cloned is in RPKI Labs. So there we are, RPKI Labs, lab setup, and Ansible. And we're going to start with the first task. We're going to change from the router to the CLI. The router was configured as what we did earlier today. The BGP, the route maps that we had, the prefix list, and so on. So what we're going to do is to empty this. In order to empty it, we need to follow the following tasks, carry out the following tasks. You have this in the guide. So I'll do it over here. And we're going to execute the T0 task. This will clear the router. We're going to go very rapidly because we don't have so much time left. So when we verify the router configuration, it's like when we started the practice. So these were we had configured the interfaces only. Now if we wish to view this task, This is task 0. Over here, you will see the modules. Here we used the Cisco IOS modules that we set up. It is called iOS config. Here we used, this module is just is console mode. So we delete everything that the router had. We also delete the RPKI part. And what we do is the following. We save the configuration of every task. This is also important in Ansible. So if I need to check a previous configuration, I save the configuration and I can recover it as well. So now, very rapidly, we will execute tasks 1, 2, 3, 4, and 5. Before that, if we put show BGP in the router, we don't see anything there because this hasn't been configured as we had done at the beginning. So now we execute the 5 tasks all together. I think there is an error. I put a dot instead of a comma somewhere. So there, I'm doing everything that we did today. So T1, 2, and 3 were executed because there was a typo there. So we're now going to do tasks 4 and 5. All this is kept in the page, in the web page, and will be around all week, so you can check this out with us if you wish. So go back to the router and I put show BGP, and we return to the status that we had initially today. In other words, with the routes that we had. Now we will automate a task that we haven't done so yet. What we have seen so far is how to use RPKI and how we can filter the valid prefixes and the invalid prefixes. So now we're going to use a different technology, one you saw this morning with Erica and with Guillermo, which is using information in an IRR. We will now see how we can automate that information. It's very important to advance, and I know that we're at the end of the day, everyone is tired, but take that into account. And especially, very often these are maybe more advanced, and you know, the automation which has to do with experience. But we need to consider something, and this is that LACNIC always offers the option for provide training. And like we said at the beginning, the prizes that we gave, all this was sponsored by Campus LACNIC. And it is important to tell you that you do have access to online training like this. Mariela Rocha is here, who is a Campus LACNIC coordinator, who can tell us more about this important actions that LACNIC does, so that you are also informed about these options.
Hello everyone, good afternoon. Just very briefly, tell you that this topic and the ones that we discussed earlier this morning and earlier this afternoon are part of our LACNIC Campus program. How many of you are familiar with LACNIC Campus? Okay, good. Quite a few of you. That makes me happy. Quite a few of you are familiar with LACNIC Campus. It's an online training platform that right now we are offering 22 online courses. And what is great is that we have a degree program available to be certified as ISP network operators, data center network operator, and campus network operators. So if you are interested in these topics, please look up the programs available on the campus, like Advanced Network Management, Basic or Advanced IPv6, RPKI, PGP, Security, and so on. So it's just very briefly an invitation to participate and to engage with Campus LACNIC. Courses are free of charge for associates, and please make the most out of them. Please sign up. Remember, campus.lacnic.net. That was all. Thank you, Silvia. Thank you, Mariela. Let's continue. And as we saw this morning, Guillermo and Erika showed how to get information from an IRR. We are going to use the IRR from the owner, from Nico. Nico is the owner. And it will retrieve some information. As you can see, we have the prefixes, the IPv6 prefixes, route 6, another object or another prefix /33, another /34. But we will focus on the ASZ objects. And we have several defined. Remember that this has been prepared for this laboratory, particularly these objects. So we have an ASZ, AS64135. The name is lab RPKI permitted. And then we have another one that refers to ASs from instructors. So each one of us uses AS65125, and 65,000 uses the router that performs as the IXP. So what we will try to do is to generate the setting for the router considering this AS set. We're saying that we're only going to permit prefixes that are originated by those of AS sets from the tutors. If we go back to the router, we still have the route hijacking. Remember that the last prefix that we see here, 280399108000/48, is generated by Sylvia's AS number 2. It's originated here, and then we have the border router AS 65,000. So what will be used? BXPQ4, and let's do it from ANSO directly because we don't have much time. So in task 6, we will try to generate the configuration for that router using BGP Q4 and invoking or using that IRR registry is the AS set. This will produce AS paths, several to filter. So we'll go back to the router. We once again execute show BGP. We don't apply that path yet. So we'll execute task 7, which will apply it towards the neighbor we're communicating with, which is the border router. So our route map, the BGP in this case, will only accept prefixes that are originated from the tutor. So when we go back to the router and execute show BGP, I only see the route or the prefix for the route hijacking originating for an AS that does not match. Now, my question is, how can we eliminate this prefix? What we did was to apply a filter to eliminate, in my example, to only keep routes that are originated from the tutor's ASs. So what can we do to also eliminate this one that is invalid? We have a pen, right? A pen for whoever has the correct answer.
De bambú, nuevecito.
A new one. It's a bamboo pen, a brand new one.
Bueno, vamos a dar una ayuda.
So we'll give you some help. We're all tired, it's late. So with task 6, we created a route map that once we've defined the access lead and the S path, and it's applied to this route map. So this route map tells me I will match the AS path permit list. When I apply it to BGP to the peer, I will apply the permit sum ASN right here. And if we look at the settings, the one that we just saw, we filtered by IRR, but we are not filtering by RPKI because the prefix is still hijacked. So what should we do? What do you think? Okay, good. A brave one. Hello. Fernando from Peru. I would add an additional sentence in the route map to deny the invalid routes. Okay. My name is Marco Torres, VisaNet from El Salvador. This is automating. So, following the same scheme as before, we need to apply the task, but in the central router. The task? Yeah, the task to eliminate the hijacked path. No, what we're trying to do, we're working on our router. And we want to eliminate the In our router, we don't want to see it. It's true, what we discussed today is for our PKI to work, we need to have it in all routers involved in the path. But what we are trying to do here is to apply a local filter to eliminate the RPKI. So what we're doing is what we did earlier. If you remember that we used a filter, we couldn't find the hijacking anymore, but the MTR would still show that it was active. That's because of the border router. So what we are now doing, we need to filter by RPKI. It's correct what he said earlier. It is important to do it across the entire path, as you said. But what we're trying to do here is for our router to filter prefixes to see how an IRR filter applies. So we are adding both. We are aggregating both conditions in one single filter. So what we do right now, what we will do right now to wrap up, is to execute two tasks. We'll do it at the same time. You have all of the information available on the website to review, and you can ask any questions. In task 8, I will create a route map involving both conditions. We'll do it one by one. Sometimes you are fully automated and you don't write as much, and you get used to it. Okay, so right here, what we have is a route map that involves both filters. And right here, we will apply it.
Volvemos al router y nos fijamos.
We'll go back to the router. In this case, there are no prefixes. In our router in particular, we filtered using BGPQ4 from an object that we've obtained querying LACNICS IRR. It is a specific object that this is an ASet, meaning that the policy is that I only want, in my router, I only want to see prefixes that are originated by tutors. Since there is a path hijacking from a tutor, in my BGP, I will only see the hijacking. And with that RPKI, I've eliminated it.
Bueno.
Okay, I know that we rushed through this part, but we're here for any questions that you might have. We're here with Nico and Silvia the entire week, and that brings us to the end of our tutorial. Guillermo? Okay, this brings us to the end of our day, of our first day. We wanted to thank the instructors, those of you who stayed, who are here in person, and those of you who joined remotely. And well, we at 6:30 we have a welcome cocktail by the swimming pool, and we'll meet tomorrow again at 9 local time, 3 p.m. UTC for the opening event. We have last mile connectivity challenges for limited connectivity, technical trends, LACNOG session, among many other activities. So once again, thank you for staying until the end, and thank you to the instructors for this lab. Thank you all.